Okay, so we're on the last 10 questions. All right, so number 31 says find the equation for a line that best models the data below. So this is going to be a lists and spreadsheets problem. All right, I know x comes first, so the top is my x, the bottom one is my y. So I'm going to go ahead and use my calculator to input my x and y. So I'm going to add a new document, never save, and go to list and spreadsheets. Do not forget to put your x in the A box, your y in the B box. Okay, so enter your values. Please make sure you're typing carefully. It's never a bad idea to go back and make sure you typed everything correctly. And I always like to make sure that I'm inside a box, underneath. I don't want my cursor showing. I just want to be underneath the data. Okay, so now I want my M, my B, and my R to pop up. So remember, to get that, we have to press Menu, Statistics, Option 4, Stat Calc, Option 1, Menu, 4, 1, and it's Linear Regression, which is Option 3. So Menu 4, 1, 3. So I want to put an X where it says X list. I want to put a Y where it says Y list and click OK. All right, so now when I scroll through, I have my M, my slope, I have my B, my y-intercept. This problem was asking for the equation, so these are the only two numbers I need. So my M, my slope, and my B, my y-intercept. So remember, it's y equals mx plus b. So we know our slope was a positive 2.76-ish. So I know it can't be A or B. And we know our B, our y-intercept, is a negative 7.26-ish. Negative 7 point. So I know it can't be D because that shows a positive y-intercept. So my answer is C. Okay, on 32 it says, which graph can be used to find the solution to the system of equations below? So notice it gives me two equations. And my answer choices are pictures of graphs. So let's graph these guys. Notice neither one of those are y equals, so when I go to my graph, I'm going to have to change it to relation. So I'm going to delete my equal sign, pick option 6, and type in my first equation, which is 2x plus y equals negative 4. Okay, that's only one of mine. So now I need to click tab so I could type in my second one, which is 2x minus 3y equals negative 12. All right, so this is what my graph looks like. I notice they intersect over here at this point. Okay, so now all I have to do is compare this to the graphs on my paper and find the one that matches it. So this looks like, let's go look. Nope, here it is, option D. Okay. The table below shows the height h of two trees that were planted in the same year. Both trees grow at a constant rate. What system of equation models this situation? I really don't like this one because it has two tables put into one. Notice we're looking at tree 1 and tree 2. So what I'm going to do is I'm actually going to make two separate tables. Where am I going to do that? I'm just going to box this off. And I'm going to make tree 1 right here. And tree 2 here. So for tree 1, the year is 0, 1, 2, 3. And the height of tree 1 is 2, 4, 6, 8. For tree 2, the year is still 0, 1, 2, 3. But tree 2 has a height of 6, 7.5, 9, and 10.5. Okay. Okay, so now that I have them separated, just makes a lot more sense to me. Hopefully it does for you too. So I'm going to look at tree 1 and tree 2 separately. So first, tree 1. Okay, first thing I want to figure out is what is my y-intercept? Well, I know my y-intercept is the y value and x is 0. So I know my y-intercept, the starting point of tree 1, is 2. So 2 feet. Next thing I want to think about is the rate of change, the slope. So let's find the rate at which tree 1 is growing by. So every year, let's see how this tree is changing. It's going from 2 to 4 to 6 to 8. So each year this tree is growing by 2 feet. So I know tree 1 has a y-intercept, a starting point of 2, and its rate of change, its slope, is also 2. All right, now let's look at tree 2. Let's find its y-intercept. So the y value in x is 0. So this tree started at 6 feet. Now I need to find its rate of change. At what rate is this tree growing by? So I know each year it went from 6 to 7.5 to 9 to 10.5. So I know that this tree is growing by 1.5 feet. So why is that helpful? Y equals mx plus b. Remember, m is your slope, the rate of change, b is the y-intercept. So if I go up here, I have 1, 2, 3 options that are in slope-intercept form. So let's go see if we can eliminate or find my answer. So on option A, it says my slope is 1 and the y-intercept is 2. Well, that doesn't match either one because neither one of these trees had a slope of 1, so A is wrong. Let's look at B. On the first equation, it says my slope is 2 and the y-intercept is 2. Well, that matches tree 1. Notice our slope is 2, the rate at which it's growing, and its y-intercept is also 2. But never check 1, let's check this guy. So this one tells me the slope is 1.5 and the y-intercept is 6. Well, that one does match tree 2. Notice my slope is 1.5, it's growing by 1.5 every year, and its y-intercept, its starting point was 6. So the answer is B. Okay, on 34 it says, what is the solution to this system of equations? So we've taught y'all a few ways of doing this. We're going to talk about the 2 easy ways, so let's go ahead and write it down. One of the easy ways you can do it is you can graph and find the intersection. Or, my personal favorite, in a calculator, you can use menu, 3, 2, and a regular old calculator page. Okay, so I'm actually going to do both ways with you just so you can see them both. So the first way I'm going to do it is by graphing an intersection. So let's go add a graph page. My first equation is not a y equals, so I'm going to have to delete the equal sign and choose relation. And I'm graphing 10x minus y is equal to 56. But I have to graph my second one as well, so I click tab. And my second one is y equals a big fraction, so control divide. On top, I have negative 12x plus 80. On bottom, I have 2. All right, there is no reason to zoom out because I can already see where these 2 lines intersect. So I'm going to press menu, analyze, intersection, so menu 6-4. So make sure that you are not on top of it. You want to be somewhere to the side. It doesn't matter which side. As long as you're on the side of the intersection, click enter. Now start dragging using your touchpad. When you drag, you're going to create this gray space. Remember, you want your intersection inside that gray space. 6, 4 is the point at which they intersect. 6, 4. All right, so remember, that's only one of the ways. Perfectly fine, we found our answer. But just to show you the other way, we're going to go to a calculator page. And I'm going to press menu, 3, 2. Remember, it's a system. I do not have to change my variables because the variables in those equations is x and y. All right, one box for each equation. So in the top box, 10x minus y equals 56. In the next box, my second equation is y equals, control divide, negative 12x plus 80 all over 2. 6, 4. So notice, no matter which way you choose, you'll get the same answer. So what do you like best? Run with it. Okay, it says, how many cases of chocolate bars will this company need to sell in order for costs and revenues to be equal? So notice it gives us our two equations. We want those two lines to be equal, so aka where they're going to cross. So this is the same type of problem. So I need to find the point at which these two lines will intersect. Okay, so like I said, you could either graph or you can use menu 3-2. The reason I like menu 3-2 is because on a graph, sometimes you have to zoom out, which I will show you on this one as well. So again, I'm going to show you how to graph this to find the intersection, and then I'll use menu 3-2. But this is the reason I like menu 3-2 better. I'm going to go ahead and graph these. Okay, my equation said y equals. This means y equals, so there's no need to change it. I'm going to type in 30,000 plus 5x. Just because you can't see it doesn't mean it's not there. That first number was 30,000. That's really large. All right, so I'm going to click tab and type in my next equation. Remember, this already means y equals, so there's no need to change it. 10x. All right, I cannot see where they intersect. So what I'm going to have to do is press menu, window zoom, zoom out. Guys, keep this magnifying glass centered over the origin and then just click enter. It zooms out. I still can't see where they intersect, so I'm going to zoom out. I'm going to click enter again. Click enter again. I'm going to continue to click enter until I can finally see where they intersect. Almost there. Boom. Perfect. I can see where they intersect right here. So now I can press menu, analyze, intersection. So make sure you're on the side of that intersection, on whichever side, it doesn't matter. Click enter. Now use your touchpad to drag to create that gray space. All right, here's another reason I prefer menu 3-2. So we get this, guys. This is scientific notation. What this means is I just need to move my decimal point, since it's a plus, to the right 3 spaces. So really, I would have 6 with 3 zeros behind it. This would be a 6 with 4 zeros behind it. If you don't like this, freaks you out, don't worry, we have another option. Oops, I need to go to graph. I'm just doing my calculator page. Menu 3-2. I am using x and y, so okay. Let's just type them in. Y equals 30,000 plus 5x. Y equals 10x. I'm going to write that down. I know it's not A or C, but B and D are both options, so I need to figure out, how do I know which one's which? Well, read the question. It says, how many cases of chocolate? So it's asking how many cases of chocolate. So look at your X and your Y axis. Read. This X is the number of cases, Y is the dollars. So if it's asking for the number of cases of chocolate, that's this guy, which is the X. So I know it's talking about 6,000 cases. This is talking about dollars, $60,000. So I wanted cases of chocolate, so my answer is B. So that's why it's good to know both ways. If you like graph and intersection, that's perfectly fine, but it's also helpful to know menu 3 too. It says a school computer lab has 48 computers. Some of the computers are laptops and some of the computers are desktops. If the number of laptop computers was 3 more than 4 times the number of desktop computers, how many laptop computers are in the lab? All right, so the question is asking me how many laptops. So I'm going to let L stand for the number of laptops. That's not my only unknown. The other unknown is how many desktop computers. So I'm going to let D stand for the number of desktops. So now that I've identified my two variables and labeled what they stand for, now we can write our two equations. So this sentence right here tells me the number of laptops was 3 more than 4 times the number of desktops. So I see that word was. By was, go ahead and put an equal sign. Is, was, has, it's all words for equal. So it tells me the number of laptops was. So laptops, we used L to represent laptops. Was, so laptops is equal to 3 more. Well, to represent 3 more, I know I need to add 3. So I'm going to leave a space and add 3. Well, what am I adding 3 to? Well, it says 3 more than 4 times the number of desktops. So 4 desktops is D. So the number of laptops we have is equal to 3 more than 4 times the number of desktops. Okay, but we still need one more equation. I'm going to use this 48, because 48 tells me the total number of computers that we have in that lab. Well, there's 2 different types of computers. We have laptops and we have desktops. We don't know how many laptops, we don't know how many desktops, but together we have 48 of them. So I know L, the number of laptops, plus D, the number of desktops, is equal to the total number of computers, which is 48. It's glitching, guys. Give me a second. There it goes. Okay, so now that we have our 2 equations, I'm going to go to my calculator and use menu 3 too. I don't want to use x comma y because we used L comma D instead. So my first equation said L equals 4D plus 3. My next equation says L plus D is equal to 48. Be careful, guys, because you have to pay attention to this piece right here, L comma D. So L is laptops, laptops is the first number. D is desktops, desktops is the second number. So laptops is 39, desktops is 9. So laptops, desktops, and it asks for laptops, so it's asking for the first number, which is 39. Okay, on 37 it says, what is the value of y in the solution to this system of equations? So we're trying to find where these 2 lines will intersect. Remember, we have 2 options. We can graph or we can use menu 3 too. Again, guys, sorry it's repetitive, but I'm going to show you both ways. All right, so let's graph first. Practice makes perfect, so make sure you're following along doing it yourself. Okay, it's not y equals, so I have to change it to relation. It's 3x is equal to 2y plus 14. I'm going to click tab to type in my second equation, which is y equals negative 6x plus 18. There's no need to zoom out because I can see the intersection point right here. I'm going to press menu, analyze, intersection. Make sure you put your intersection point inside that gray. So 3.33 and negative 2. So you can write that down if you want. Let's do it the other way. go to our calculator page. Menu 3.2 in our calculator. We are using x and y, so no need to change that. 3x is equal to 2y plus 14. Y equals negative 6x plus 18. Okay, this is the exact same thing, it's just written differently, guys. 10 over 3 is the same thing. Watch. Put a little decimal behind it to change it. Same thing as 3.33. So we got the same thing either way, just in a different form right here. All right, so I'm going to go write that down. Oops, I already forgot. Okay, so I see my answer choices are either A or C. But obviously I can't pick both of those, and I don't want to because it's asking for the value of the y. So it's x comma y. So my answer is negative 2. All right, so I see it gives me an inequality. And my answer choices are pictures of graphs. So let's graph this guy. I'm going to delete my equal sign and change it to relation. And I'm going to type in x plus 2y. To get that inequality symbol, we press Control equals. Take your time, make sure you pick the one that does match exactly, which is this top middle one, negative 14. All right, so from here, guys, what I like to do is sometimes it's hard to tell whether this is a solid or dotted line. It looks pretty solid to me. But if you take your cursor and you come over here and you click on it, or hover over it, it turns it bold. So once I'm hovered over it, I can clearly see that it's a dotted, a broken line. So now I want to pick which one on my answer page looks just like this guy right here. So let's go look. That looks like option F. Well, let's think, how did I also know that it should have been a dotted broken line instead of solid? Well, if you look at your symbol, notice your solid or equal sign is missing. No solid line, no solid line. All right, this is another graph problem. It says, which inequality does the graph shown below best represent? So right here, notice all of my inequalities. So we could just graph one of these at a time. But let's think about the math in it. Because you know how to graph. You can do that if you wanted to. But let's actually think this one through. Let's look where that shading is located in comparison to our line. Our shading is underneath, below. So if our shading is underneath, below, I know that we need a less than sign. I also notice that this is a solid line, so I need my solid or equal sign underneath. So remember, this happens when y is already by itself. You can't really do that. Follow that below or above thing if y is not by itself. But since my answer choices all have y by itself, I see that the shading is below. I need the less than sign. It's a solid. I need a less than or equal. So I know I can eliminate option B and C. Okay, so the difference between A and D. So they look pretty similar. The only difference is here is a positive 2, here is a negative 2. So that's my slope. So do I have a slope of a positive 2 or do I have a slope of a negative 2? Well, guys, look at your line like you read a book from left to right. This line is going up, which tells me the slope has to be a positive, which is why answer choice D is wrong. And the answer is A. So like I said, you could have just graphed y less than or equal to 2x minus 4. When you graphed it, you would have noticed it looked exactly like this. Just different options. Okay, number 40, state which region of the graph contains the solution set to the inequality shown below. So what I'm going to do is I'm going to graph these two guys. I'm going to change it to relation. Type in my first inequality, y. Control equals, make sure you pick the right one, it's the very first one. Negative x plus 1. Now I'm going to click tab so I can type in my second one. Y. Control equals, this is the bottom middle. 2/3 x plus 2. Okay, I have a lot of students that when I ask where are my solutions located, they tell me the shaded area. Well, on this, that's not necessarily true because this is shaded, but these are not the solutions. This is shaded, but this is not the solutions. When you have two inequalities, it's where the shadings overlap. Well, I know blue and red together make purple. It's this darker section right here. So this section is where my solutions lie. So we need to look on our paper and figure out which answer choice matches this section. Well, that looks like option C. All right, bye y'all.